Hi, my name is Kenwin. I'm a sophomore. I'm 15 years of age, and I would like to attend GHP. I want to attend GHP in the mechanical and electrical engineering pathway because I would like to further expand on the knowledge in the field. Now, as a part of my application process, I'll be showcasing 4 projects that I've been working on and how they've each shaped me. Now, one of my projects was home automation. I noticed a problem I had every night. I would get into bed, but I forgot to turn off the lights. So then I have to get out of bed, walk over to the light switch, walk back, get back into bed, and by then I'm not even tired anymore. I thought convenience should be key, so I developed a system that uses voice recognition software to control certain aspects of my house through a Wi-Fi enabled Arduino and a relay board. Using a Arduino to control a relay board, which then turns on and off power. For an example, using a command, I could turn on or off this light over here. Computer, turn on all power. This project taught me crucial skills I needed for my career, such as soldering, circuitry, how to read schematics, and even coding. Another project I did was making my own plane, which is behind me on this wall here. This is a clip of Autodesk Inventor and the wing including the ailerons which control its flight. Now this mechanism is controlled through a series of push rods and bell cranks, and this goes from the fuselage yoke to the wing itself. The plane itself was made from aluminum conduit with foam core wings to reduce its weight. Now the wings and the fuselage was fiberglass and epoxied over to prevent cracking and breaking apart. The rudders and the ailerons and elevators are all made out of plywood, and the propeller was bought, and the plane itself was propelled through a electronic EDF and LiPo batteries. Another project is drone deployed aerial ignition devices. Now, in this project, I use a drone to remotely deploy aerial ignition devices. These are polycarbonate capsules that contain potassium permanganate, and when they're injected with ethylene glycol, they will spontaneously combust with the delayed reaction. Now, depending on the particle size of the potassium permanganate and concentration and purity of the ethylene glycol, you can control the reaction rate and the delay time. For this project, I used a Arduino connected to a Bluetooth host shield to communicate to a Sony PS3 controller via Bluetooth dongle. Now this PS3 controller is modified to where it can connect with a larger bandwidth.
There we go. But that is very hot. Very, very hot.
Where'd it go up to?
Right now it's still going up and it's at 450.
The Arduino controls servos and linear actuators to control this mechanism right here. The mechanism you see here is mostly made out of ABS plastic with fiberglass infused for more strength, and all these parts are all aluminum. And they are right here. Okay, so it's done compiling and it's uploaded. So let's open up the serial monitor. And we have this which tells us what's going on. Alright, so now that that's done, we can plug this thing up. Oh wait. So turn on the controller. Alright, so it's gonna flash. That means it's pairing. And once it turns solid, that means it's paired. Alright, so now try to move any of the axes. When you do that, there's instantaneous feedback on the data endpoints of the controller. So try the buttons. So yeah, it will tell you cross, circle. It's not showing up the whole thing, I don't know why.
L1, L2,
yeah.
all that.
Right. This is the first project where we moved from blank PVC boards to integrated circuits.